can say attract each other, but if they are both negative or positive, what will happen that they will repel each other. So we see this in our daily lives like in magnets. So what are the key differences? So electromagnetism is a very long range force, while the electrostatic is also long range, but it becomes negligible at very small distances. So the Coulomb's barrier is relevant at very small distances, typically on the order of nuclear dimensions. So electromagnetism is a fundamental force, while electrostatic force is a component of electromagnetism. And the Coulomb's barrier is also not a fundamental force, but rather it's an energy barrier arising from the electrostatic repulsion. So what does that mean? It means that in electromagnetism, Coulomb's barrier, it contains the Coulomb's barrier and the electrostatic repulsion, and the electrostatic repulsion contains the Coulomb's barrier. So it is the barrier that arises because of the repulsion or the attraction of particles. So electromagnetism contains all of them. Okay, so Sakshan, can you explain to me like what I said to everyone?
Yes, Aryan.
Can you explain to everyone what I said right now? What are the key differences between electromagnetism, electrostatic force, and the Coulomb's barrier?
What are the key differences between
Electromagnetism, Coulomb's barrier, and the electrostatic force.
electromagnetism and Coulomb's barrier?
Uh, can you repeat?
Electromagnetism and Coulomb's barrier.
And electrostatic force also.
Oh, and electrostatic force.
Yes.
Uh,
You have any simple ideas?
in electromagnetism, the electrostatic force and the Coulomb's barrier are distinct concepts in physics. Though they are related by their connection to electric charge, electrostatics is a static, non moving aspect of electromagnetism, while the Coulomb barrier is a specific application of the electrostatic force in the nuclear physics.
Okay, like, can you explain it in very simple words? Okay, so I can explain it. So, electromagnetism contains electrostatic force and the Coulomb's barrier, and the electrostatic force contains the Coulomb's barrier. So, the Coulomb's barrier is not a fundamental force, but it is a barrier arising from the electrostatic repulsion that is happening between the charged particles. You get it now? Okay. So, Sakshan, I have a question for you. Okay. So I think we should continue with the topic, the strong nuclear force. So the strong nuclear force is the strongest of the four forces in nature. It's responsible for holding the nuclei of atoms together, especially binding protons and neutrons within the nucleus. So this force overcomes the electrostatic force that happens between positively charged protons, allowing for the existence beyond atomic nuclei of hydrogen. So, Saksham, I have a question for you. So, why there are no further elements than organelles? Can you explain?
No, Aryan.
Okay, so you see that the strong nuclear force is responsible for holding the nuclear together. So if there are more numbers of neutrons or protons, what will happen that it will, you can say, it will be more, it wants to decay, and that is why there are no further, that is why there are no further elements. So Saksham, do you know what is the natural heaviest element that we didn't create?
I think gravity.
No, it's uranium. Okay, like in a neutron star, you have seen that all of the, like most of the things in a neutron star are neutrons. So why don't they just scatter in a space? Do you have any idea?
Means you are asking that the neutron star is made up of neutrons.
Yes.
But why does this scatter?
Why don't they scatter? Yes. Like, how is that stable? There are so many neutrons, and there is the electrostatic repulsion, which says that two like uh, charges will repel each other. So why is that stable?
Um, I think because of the immense gravity of neutron star or this vacuum of the space is empty.
Uh, it's not a valid answer. It has a very strong gravity, but you see that it's because of the strong nuclear force. You see that it keeps like everything, like neutrons, protons together, or else even anything surrounding us will not be possible, because if there are two like charged particles, they will repel each other. Yes.
Okay, Aryan.
Okay. Properties of strong nuclear force. So it operates at subatomic distances roughly within the nucleus. So the strong force is mediated by particles called gluons. It overcomes the repulsive magnetic force between protons. So, Fiction, do you have any idea where are these gluons present? Hello, Sakshan and Harun, do you have any idea like where are the gluons present?
Gluons, I think they are present in a similar area of. I don't know, Aryan.
Okay, so you see that a proton, I think yes, a proton, no, a neutron is made up of two down quarks and one up quark. And so, how are they like in the neutron? They are they are held together by the strong force which is mediated by the particles called gluons. So what will happen that if you try to break it, it will use that energy to make new pairs of that quark. So you can't really break it, but in very very high pressure and intense spaces like the cores of neutron stars, uh, they might break, and what happens that a gluon, the gluons melt away, and quarks are deconfined that way. And if the pressure is very high enough, what would happen that the weak nuclear force will convert half of the down quarks into strange quarks, and the strange quarks will go and infect everything, making strange matter and other things. So yes, these are the properties of strong nuclear force. So they are very essential, and the gluons are found between the quarks, and they are held together by gluons. So that is how protons and neutrons exist, because of gluons. Okay. So, ladies and gentlemen, any questions? Any questions by anyone? Okay, no. The strong nuclear force, or the powerhouse of the nucleus. So, the strong nuclear force binds protons and neutrons together in atomic nuclei. It is the shortest of the four forces but has a very long range. So, short range, this force is essential for the stability of atoms. So, you see that neutrons and protons are there, and they are connected by the strong nuclear force, which is mediated by the gluons. It is the strongest of them all, but it has a very short range. And this force is essential for the stability of atoms. Okay, so okay, Saksham. So I have a question for you. Do you know about Dyson's cold thought? Hello, Saksham.
Yes, Aryan.
Do you know about the Dyson's cold thought?
No, Aryan.
Okay, so like this can be my next topic. So in this, what happens that let's assume that the energy and time it takes for a person's brain at 20 degrees Celsius is 10 joules, and it takes 1 second. If we decrease the temperature, like half it, the energy will be also halved, but the time will be doubled. So this is the Dyson's cold thought, and this might be like, you can say, a way to live forever. But what happened? But there's one thing, that human flesh cannot like go under uh, go under very high cold temperatures. So advanced civilization might upload their brains or virtual reality, you can say, and they will cool down, and so it's a very complex topic,
Okay, Aryan.
but it might help us live for eternity, but there are many side effects of it also. So okay, let's get to the topic. Why does radioactive decay occur? So radioactive decay are happened because of the weak nuclear force. So when decay occurs, an unstable nuclei seeks a more stable configuration. So, this imbalance in nuclear forces causes certain isotopes to decay. So, this decay helps nuclei to reach a lower energy state. So, these types of decay, like the beta decay and the alpha decay, are mostly possible by the weak nuclear force. So, in beta decay, what happens that uh, it can happen through two processes, the R and S process. The R process is the rapid neutron capture, and the S process is the slow neutron capture. So in R process, this rarely occurs like in neutron stars, you can say. So in this, what happens that the nuclei gets way too many particles, and let's say if it has more neutrons, so what will happen that it will try to decay, and what will happen that it will convert the neutrons into proton and will also release a beta particle or an electron. So that is how beta decay happens. And alpha decay also happens with protons turning into neutrons. Okay. So which force is responsible for the decays? So Saksham, can you read this slide?
Which force is responsible for decay? The fundamental force responsible for decay is the weak nuclear force. This force plays a crucial role in certain types of radioactive decay, such as beta, beta decay, where a neutron transforms into a proton, emitting an electron and antineutrino. Weak nuclear force is one of the four fundamental forces of nature alongside gravity, electromagnetism, and the strong nuclear force.
Okay, the fundamental force responsible for decay is the weak nuclear force. So this force plays a crucial role in certain types of radioactive decay, such as beta decay, where a neutron transforms into a proton, emitting an electron and an antineutrino. So this weak nuclear force is one of the four fundamental forces of nature alongside gravity, electromagnetism, and the strong nuclear force. So this is the force which is also like help us understand strange matter. So Saksham, do you know how weak nuclear force helps in forming strange quarks?
No, Aryan.
Okay, so you see, like when a very massive star dies, the protons and electrons are squished together and they form neutrons. So a neutron star is mostly made up of neutrons, and a neutron is made up of three quarks, one up and two downs. So what happens that the gluons, the strong nuclear force meditators, uh, are melted away in very high and extreme conditions. So what will happen that quark deconfinement will happen, and it will be a soup like a material, and then because of weak nuclear force, what will happen that nature will turn half of the down quarks into strange quarks. So that is how strange quarks are formed, and then they go on and infect the whole star, making strange matter and strangelets. So this is how a strange stars are born because of a weak nuclear force. It changes the quark's flavor type. It what happened that the down quark was changed into a strange quark. So that is how it is done. So now you understand, right? Okay, so we okay, so we go to the next one, gravity. So gravity is the force of attraction between masses. It is the weakest of the four, but has an infinite range. Gravity governs the motion of planets, stars, and galaxies. So you see that gravity is the force of attraction between masses. It is the weakest of the four, but has an infinite range. So, Saksham, have you heard of the three body problem?
Yes, Aryan.
So, can you explain to us what is the three body problem?
No, Aryan. I only heard about it.
Okay, so what happens? Like three celestial bodies are there, And like in a two body problem, it is very simple. They might start rotating around each other, and you you know about it. So they might, in the two body problem, they might also have a center, like baryonic center, where the other star rotates around it, and the bigger star also rotates, but in a more centralized position. But in a three body problem, what happens, that it's pure chaos, and it is it is bound to chaos, and predicting it is very chaotic. So it's very hard. In this, what happens, that simply there are three celestial bodies of around the same mass, like three stars in a position. What will happen, that chaos, there will be only chaos, and predicting it is very hard. So, like when Newton discovered the laws of gravity, he was faced with this problem, and he and someone else, I think, developed some differential calculus and solved it. He could also have done it, but he didn't. So it is a very old problem, you see. It mostly results in a system of chaos where they might be thrown off, or they just collapse. Okay, you understand it, right?
Yes, Aryan.
Okay, so the properties of gravity. So gravity always attracts, it never repels. So it is described by Einstein's general relativity, has the curvature of space-time. So gravity is responsible for the formation of the universe large-scale structure. So, uh, Saksham, do you know why gravity accelerates everything at the same rate?
Yes, Aryan.
Why does gravity accelerate everything at the same rate? Like nine. Why?
No, Aryan.
Okay, so you see, if we have two balls, let's name them ball A and ball B. So let's assume that ball B is 10 times harder to move and is more massive than the first ball. So when we drop them, what will happen? That they will reach the ground at the same time, but the in ball B, what is happening, that gravity is applying much greater force, and it is getting cancelled by its resistance to move, like because it's more harder to move, you see. Let's assume that ball B is 10 times harder to move than ball A. So what will happen, that it will exert 10 times more force, but the ball is 10 times more hard to move. So it will just cancel out, and they will accelerate to the same rate. You understand it, right? Hello, Sakshi.
Yes, Aryan.
Did you understand what I was saying?
Yes, Aryan.
So, nature just, you can say, is very awesome. It uh, takes more force to make a harder ball move, and it applies this perfect amount to always cancel out them. Okay. Okay. So, Saksham, do you have any questions?
No, Aryan.
Okay. So, like any general questions, like any of them.
No, Aryan.
Okay. So, do you know, like, if we are on Earth, so we are getting pulled downwards. So, like, do you know what is down then? Are you getting it?
I did not understand your question.
Like when we are on Earth, we are getting pulled down. So do you understand down?
Yes,
But like for another person, down is just another thing.
yes.
So so which way is down? Do you know that?
Um, I think so. Down for the people on the earth, the down will be the surface of the earth or the core side.
Okay, so for us, the down of Earth will be the center because gravity is pulling everything down at the center of Earth. But you know that the center is also like not at a fixed place. There is molten magma. Uh, there are many plateaus, many platforms. So
Yes,
it's always changing a little bit.
yes, Aryan.
And one more thing, everything is pulling at you. So what will happen that if you weigh yourself when the moon is above your head, you will be a little bit less. You can say lighter, like 1 millionth of a gram lighter, because the moon is pulling at you.
Yes, Aryan.
So it does not mean that your mass changed. It meant that the weight changed. So like mass remains the same in every place. Only the weight is changed. If you're on other planets, the weight changes because of the gravity. Okay. Why does gravity accelerate everything at the same rate? So Einstein's principle states that gravitational and inertial mass are equal. So this means that gravity's effect is indistinguishable from acceleration in a small enough region. This principle helps explain why all objects fall at the same rate regardless of mass. So that is just the thing that I explained. So like these types of things are very hard to understand, and they should be explained in very simple terms. So it means that if I have two balls and the other ball is 10 times more hard to move, so that ball, gravity will pull it to the center of the earth 10 times harder, but its resistance to move will be 10 times harder. So it will just cancel out, and that is why gravity's effect is just indistinguishable. So if you are in a rocket that is accelerating at 10 meters per second in space, you will be feeling the opposite force. So what will happen that you will be almost feeling the same force as on Earth. It happens because ship is going, the rocket is going up, and the normal force that will be applied on you will be downwards, the opposite direction. So that is why we experience gravity by Einstein's uh, special relativity theory. So it states that we are not moving down, the ground is moving up. So it means that if we are jumping, the ground is moving up at a speed of 9.8 meters per second. So that is why we are experiencing the, can say, the opposite force, and that is why we are feeling gravity downwards. So Einstein's special relativity explained it that way. Okay, so section, did you get it right?
Yes, Aryan.
Okay. Okay, so hello, Abhishek sir. Hello, sir. Are you here? Okay. So the principle of equivalence. So it states that the gravitational and inertial mass are equivalent. So this means gravity's effect is indistinguishable from acceleration in a small enough region. This principle helps explain why objects fall at the same rate regardless of mass. So, Saksham, do you know how to calculate the gravity between two forces?
The equation of the gravity is 2m squared.
Can you repeat?
I think we can calculate the gravity on the other objects by comparing the gravity of that object from the earth.
Okay, so I was asking you like, do you know how to calculate the gravity between two objects in space? Do you know about it?
So suppose I am calculating the gravity between Jupiter and the earth. So we know the gravity of the earth, but to calculate the, but to compare the gravity of the earth and Jupiter, so first we need to learn the gravity of the Jupiter, and then we can compare the both gravity side by side.
Okay, so the thing I was asking is a little different. So suppose there is like say object one in space and object two in space. So how we will like uh, you can say calculate the gravity between those objects. So do you know about it?
I think that I think by contracting their mass or etc.
Okay. So we can take the mass of the first object and the mass of the second object and divide them by their like you say distance squared, and then multiply it by the big G, which is the gravitational constant. So what we are doing that we are multiplying both of their mass and dividing it by their distance squared, and then multiplying them by the big G, which is the gravitational distance, and then we can find the force of gravity acting upon them. You got it?
Yes, Aryan.
So can you explain to me what I did here?
Aryan, I have one question.
Okay.
Aryan, I have one question that scientists can measure the gravity on the other objects, like we can measure the gravity of the Jupiter by comparing its gravity to the Earth. But if suppose there is an object whose gravity is infinite, or you can say close to infinite, like, so how can we compare its gravity from Earth?
Okay, so an object with near close infinite gravity does not exist, because near infinities does not exist. Like with if like say I have a number that is like you have heard about Google Plexes, Google Bang Bang, which is just like way too large to imagine even. So if we have like these numbers, they are closer to zero than infinity. So near infinity does not exist, and infinite gravity is like not a thing. So you won't be able to measure it. And I think that if it has infinite gravity, then it will just might kill us all because of its gravity. Then
Okay, but you just told that infinite gravity is not possible. Then why black holes have infinite gravity?
oh no, they don't have infinite gravity. If they would have infinite gravity, they would be much more weirder than that. So see, there is one more thing called escape velocity of a thing, which is just I think so mass, etc. So the 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 radius of the black hole is very small, and the mass it has, it is very big, according to its, you can say, radius. So that is why the escape velocity reaches above light speed, which is not possible. And so that is why black holes appear black, and they don't have infinite gravity. They also, like, you see, they don't have infinite gravity. They have a large amount of gravity, but not infinite gravity.
Okay, Aryan.
Okay. Inertial mass versus gravitational mass. So inertial mass measures an object's resistance to acceleration. So gravitational mass measures how strongly an object with gravity interacts. So experiment shows that these types of mass are equal, leading to a uniform acceleration. So this is the same thing. So we have two things. One is 10 times more hard to move. So gravitational mass will, you can you can see that it will apply 10 times more force, and they will just cancel out. So inertial mass and gravitational mass are always the same. So that is why they cancel out, leading to a uniform acceleration of 9.8 meters per second. Okay, I think Gunish has joined. So hello, Gunish.
Hello, Aryan.
Okay, so like, do you understand any of these things, or do you want me to explain in a little more deep way? So, where are you from, Gunish?
I'm from Ludhiana in Punjab.
Okay, so uh, do you want me to explain in little more deep, so you can try to understand this stuff?
Yes.
Okay, so gravity. So can you explain gravity to me? Like, what does it do? Hello, Ganesh.
Uh, just wait a minute.
Okay. I think someone named as Deepak has joined. Hello, Deepak. Uh, I think he's not here. So, Ganesh, do you have your answer right now?
Yes, yes. Gravity is the gravitational force of the Earth through which all the objects stay on the Earth, including the atmosphere.
Okay, so there are two things. One is 10 times more harder to move, or you can say 10 times more massive. So they will like reach the ground at the same time if I drop them. So can you explain to me, like, you have any idea about this?
Oh, I don't know.
Okay, so they will reach the ground at the same time because the object B, let's name them object A and object B. So object B is 10 times more massive and harder to move than object A. So what will happen? That gravity will exert 10 times more force, but they will be cancelled out by the object's resistance to move. So they will just cancel out, leading to a uniform acceleration. So that is why they both hit the ground at the same time. Did you get it? Hello, Gunesh, did you get it?
Yes, yes.
Okay, so in short, it is like, if an object is 10 times more massive, gravity will apply 10 times more force, which will lead which will just cancel out and will lead to a uniform acceleration. And we discussed some more things like electromagnetism, electrostatic force, and the Coulomb's barrier. So, Gunesh, you know that like charges, like if I have two magnets, one of them has an north pole and the other one has the south pole, so they will attract. So that also happens to the particles that are uh, positively and negatively charged. So if I have two positively charged particles, what will happen that they will repel each other, and that force is called the electrostatic force. And there is one more thing called the Coulomb's barrier, which is like when those objects are about to touch each other, the Coulomb's barrier prevents them from touching each other. So it's like a wall that is preventing them to touch. So, and the electrostatic force is the repulsive force or the attractive force between positively charged particles. And so it means, like, you see that there are atoms in you. So are you getting it, Gunish? The thing I'm saying, the
Yes,
forces.
yes.
Uh, can you repeat? Uh, Hello, Gunish. Can you repeat yourself?
Wait.
Okay. So, Saksham, do you have any other questions? Oh, he left. Hello, hello, Harun. Can you hear me clearly? Is it still raining in your country? Okay. So, the unification of forces. So the physicists aim to unify the fundamental forces into a single theory. So the electromagnetic and the weak forces are unified into the electroweak theory, and a grand unified theory, and a theory of everything remains our goals. So, Gunesh, did you understand that about the electromagnetism, the things that I said?
Can you just repeat the last one because I was away for a moment?
Okay, so like the Coulomb's barrier is the wall that prevents uh, things from touching each other, and the you can say the electrostatic force is the force that is responsible for, you can say, repelling and attracting each other. So like forces like forces repel each other, and unlike forces attract each other. So it's very simple. And there are a few more things I would like to say. So did you get it? It's very simple.
Yes.
So you see that an atom has nuclei in its center, which has protons and neutrons, and then there are electrons which orbit them. So you see that, like charged particles repel each other. So when you touch something, there are atoms in your finger, and then they have electrons. And when you touch that object, the electrons of that atom will repel each other, and it means that you're not touching the object, you are just feeling the repulsive forces between them. So in your life, we haven't touched anything. So you did you get it, Gunesh?
I didn't got it. Please repeat.
Okay, so like there there are electrons orbiting the nucleus which have protons and neutrons. So the electrons orbit around the protons and neutrons, so that makes an atom. So if you touch the other object which has atoms in it, what will happen that the object will repel you, because the electrons of your body and the electrons of that object are touching, and because of the electrostatic force, they will repel each other, and you only feel the repulsive force that happened between the electrons. So it means that you haven't touched anything in our life. uh, did you get it now? Hello, Ganesh.
Yes, I got it.
Okay. So the unification of forces. So we have tried to make a theory of everything, and like grand unified theory which explains everything: the weak nuclear force, strong nuclear force, electromagnetism, and gravity. So yeah, so the things that I mentioned, electrostatic force and the Coulomb's barrier, they are in electromagnetism. So electromagnetic force encompasses, like it contains both the electrostatic force and the Coulomb's barrier, and the electrostatic force contains the Coulomb's barrier. So Coulomb's barrier is not a fundamental force, but it is rather an wall that is created by the electrostatic force. And electrostatic force is also not a fundamental force, but it is rather a property of electromagnetism. Okay, so I think someone has joined us. So thank you for joining us. Some new person have joined us. So thank you for joining us. So where are you from? Uh, okay.
Um,
Hello. Hello, sir.
Hello,
Uh, hello,
hello.
sir. Sir, what's your name?
My name is Wake Up.
Uh, your voice is not clear.
Wake Up.
Uh, so, sir, where are you from?
I'm from Kenya.
Okay, nice. So, I have a few friends there also in Kenya and South Africa also. So, uh, do you know, do you have an interest for astronomy and science?
Yeah, of course. I know a little about science and astronomy.
Okay, so, do you understand these types of topic, unification of forces, electrostatic force, or the Coulomb's barrier? Do you understand them?
Um, Maybe I will improve that.
Okay, so I think so. You are a beginner. So, do you want me to explain something about these topics? Uh, yes.
No,
Right now, I can explain it to you if you want.
no, I don't want right now.
Okay. So, yep, I think so. We are done with the presentation then. Hello, hello, sir. So,